let's have a look at some examples of surds and non-surds. Just because it's got the radical sign, that doesn't necessarily make it a surd. Let's have a look at some examples here. So first one, part A, select the surds from this list of roots. So square root of 27, cube root of 27, square root of 400, square root of 1000, square root of 0.01. So what we do, grab your calculator and just enter them in. So square root of 27, what do we get? We get 5.196152,423. The decimal just goes on and on. There's no pattern to it. So if it's one of those recurring decimals, like, 5.12121212, so on and so on, or 5.12 recurring, that's actually rational. It's not irrational. Just because the decimal goes on forever doesn't make it irrational. So square root of 27 is irrational. So I'm just going to put a letter I here for irrational. Okay. This also means that this is a surd. Okay. So in fact, I might just write the word surd there. So this is definitely a surd. Okay. It's irrational. It's got the square root or the radical sign there. It's a root of a number. It's a surd. All right. What about cube root of 27? We get a nice integer 3. Okay. So this one here is not a surd. All right. Square root of 400. 20. Also not a surd. Okay. What about square root of, is it 1000? That's clearly a surd. Okay. Again, decimals go on forever and ever. It looks like there's a bit of a pattern there, but I can tell you from now that there's actually a lot more to the decimal. Sort of convenient that it looks like there's a recurrence there, or some repetition, but this is clearly a surd. Okay. In fact, URD. And what about square root of 0.01? Okay, just because it's a square root of a decimal, that might not be a surd. Okay, might be a rational number. In fact, you get 0.1. So this equals 0.1. There's no, it doesn't go on forever and ever. So sort of non-terminating, and it can certainly be written as a fraction. So this is the fraction 1/10. So this is also not a surd. All right. What about part B? Classify each number as either a rational or irrational. So let's call this I and this one R. Okay, so just to make it easy. All right, 12 1/3%. Can that be expressed in fraction form? It certainly can. In fact, just to prove the point, shift fraction 12 1/3. Okay, percent. Okay, it's actually the fraction 37/300. So this one is clearly rational. What about square root of 10? Okay, square root of 10, 3.16. Again, it looks like the square root of 1000, doesn't it? In fact, there is a relationship there. 3.16. There's again a decimal that goes on forever. No real pattern to this one. This one's irrational. Pi, we know that pi is in fact irrational, right? So 5 times an irrational number will also be an irrational number. And I think that's a very interesting observation. This one's irrational. In fact, just as a rule, a rational number, right, multiplied by an irrational number, okay, is in fact equal to an irrational number. I think that's a very nice little property to know. Okay. However, an irrational multiplied by another irrational doesn't necessarily mean that the answer is going to be irrational. In fact, it could end up becoming rational. What about square root of 2 times the square root of 2? No, they're two irrational numbers, even though they're identical. Multiply them together, you get a rational number. Right. What about 0.17 recurring? Okay. Now, anything that recurs, it means there's a pattern to it. It can be explained by way of a fraction. So let's have a look and see how we can simulate that in the calculator. In fact, how would you enter in 0.17 recurring in the calculator? You would type it in as 0.1 and then just press a whole lot of 7s. Fill the screen up. Okay. Press the SD button and you get 8/45. In fact, this one is rational and it can actually be proven so. Okay. We can in fact find the fraction using algebra that represents 0.17 with the 7s recurring. What about the cube root of 0.008? Okay, so 0.008. In fact, you get 0.2, and in fact that makes sense because 0.2 times 0.2 times 0.2 is 0.008. So this one is another rational number.